For this lesson, we're going to be sketching slope fields. Now, a slope field is just that. It's basically a graph with a bunch of individual slopes on them, and I'll explain how to do it, why it's important. This particular graph has a bunch of slope fields on it with some solution curves, which we're going to look at later on. But basically, that's the application of a slope field. Sketch all these slopes, you're able to sketch several curves that fit along those slopes, and those are called solution or integral curves. And this is how we tackle solving differential equations that can't be integrated explicitly, or if we just want to get a snapshot. So some students are confused by slope fields because there's so many different possibilities or possible curves for a particular equation, but that's what happens with differential equations. They have multiple different solution curves, and that's what slope fields are good for, again, when you can't explicitly integrate it. There are 4 types of questions we will be looking at for this particular lesson. For this first video, we'll be drawing a slope field. For the next video, we'll be sketching an integral curve. Then we'll be looking at isocline lines for the last 2 examples. Okay, so for example 1, we have the following equation. dy dx equals x plus 1 over y. So how do you know when it's a differential equation? Well, you're going to have a derivative. So it could be dy dx, it could be y prime. They mean the same thing. And you have an equal sign. Anytime you have that, that is technically a differential equation. Now, what makes slope fields come into play is when you have a y in the differential equation. So it's not just dy dx equals x plus 1. In that case, we could just integrate, right? We get 1/2 x squared plus x, and that's our answer, right? Plus c. But with this y in it, that's where slope fields come into play, and that's why we want to sketch them, because sometimes you can't come up with an explicit formula. For this one, you can, and in a future lesson, we'll look at how to solve this analytically. But for now, let's just look at the slope fields. It will give us an idea of what the graphs will look like. So the directions say show what the graph of y could look like by sketching a slope field for -1 for x between -1 and 1 and y between -2 and 2. So when you're sketching a slope field, you want to work with a particular range. This one ranges from -3 to 3 for x and -3 to 3 for y. Okay, and we don't have time to sketch, hundreds of thousands of slopes, right? So the best we can do is do it for a particular range of x and y values. So again, for this one, it's going to be from -1 to 1 for x and from -2 to 2 for y. In essence, this is what a slope field is. It is a sketch of possible graphs of y. Okay, and y would be the original equation. So when you sketch a slope field, what you're really sketching, you're not sketching dy dx, you're sketching y. dy dx gives you the slope, and that's why you sketch the slopes on the particular fields. And you're given dy dx. So make sure you understand that. Your x-axis is x, your y-axis is y. This is especially useful when an equation for y cannot be explicitly found. So for this particular differential equation, dy dx equals sine squared of y over y minus x. As far as I know, there's no way to integrate this and get y by itself. So the best we can do is a slope field, which will give us a snapshot of the possibilities of what the graph of y could look like. So how would you even begin to find this interval? Well, again, not really possible from what I can tell. Slope field gives you your best idea. So step 1 is going to be to sketch the field. Now by field, I just mean an x and y axis with a particular range of x and y values. Okay? We're going from x equals -1 to x equals 1, and from y equals -2 to y equals 2. So you just have this simple grid, which is actually a 3 by 5. So there will be 15 grid points to sketch our slopes. For every one of these points, we're going to have a slope that we sketch. Step 2 is to complete the chart. I'm going to explain this chart, why it's important. What I typically do is I start with my top left point. I go all the way down for the first column. Then I start at my middle, or my next column, go all the way down. And I keep it going until I'm done. In this case, it's going to be 5, 5, and 5, so I'll have 15 total points. You can plug your points however you want to, just make sure it's methodical. Another option would be to go from left to right, but you're going to see why I go column-wise, because you're just plugging in the same x value for each of the columns. So I'm going to start out with my top left point, -1, 2. and that's this point right here. So I need to figure out which slope to sketch at negative 1 comma 2. Well, here's my differential equation, x plus 1 over y. So for x, I'm just plugging in negative 1 into the equation, and for y, I'm plugging in 2. Negative 1 plus 1 is 0, 0 divided by 2 is 0. So my first slope that I'm going to sketch is 0. Now I'm going to go ahead and sketch what that actual line looks like. A line with a slope of 0 is a horizontal line, right? So it's going to look like that when I put my little line on my slope field. And we'll talk a little, we're going to go into exactly how to do that and how long this needs to be and stuff in just a minute. My next point is negative 1 comma 1. Again, I'm plugging into this equation. We see a pattern though. We're always going to get 0 on the top. So as long as we don't have 0 on the bottom, the slope is still going to be 0. Okay, and again, that line's going to look like that. I'm going to go ahead and fill in these bottom ones because as you can see, I'm going to get 0 back because we have a non-zero on the bottom. However, the middle one at negative 1, 0, we're not going to have just a horizontal line. We are going to have a 0 over 0. So we're not going to put anything at negative 1, 0 because 0 over 0 is undefined or it's an indeterminate. So there will be no slope sketch there. Okay, then I'm going to move to my next column. So I'm going to start at 0, 2, and then work my way down. At 0, comma 2, again, I'm going to plug in 0 for x into my differential equation and 2 for y, and I got 1/2. Okay, so my slope at 0, comma 2 is going to be 1/2. Now you might be asking, how do you sketch 1/2? The way I like to think of it is this. Well, actually, I'll go back and talk about how to sketch that in a second. Let's look at the next point, 0, comma 1. So what slope am I going to put at 0, comma 1? Plug in 0 for x, 1 for y, I get 1 over 1. So 1 over 1 is the easiest slope to sketch, right? I mean, I don't think it can get much easier than that. 1 over 1 is a 45-degree angle. So when I go to sketch this slope, I'm just going to make a diagonal line that's about 45 degrees. So this gives me a good idea of what 1/2 would be. Okay, 1/2 is going to be more run than rise, right? So it's going to be not quite as steep as this. It's just sketching, okay? I'm going to underline this. I'm going to underline the word sketch, okay? Sketch just means an approximation. It doesn't have to be exact. So when I go to sketch what the slope of 1/2 looks like, I'm just going to make it a little bit more shallow. 1/2 is going to be a little bit more shallow than 1 over 1. So basically, the bigger this number is, the more shallow my slope is going to be on my slope field. Okay, moving on down, when I plug in 0, negative 1, I want to figure out which slope to put there. I plug in 0 for x and negative 1 for y, and I get a slope of negative 1 over 1. So I usually put my y value as negative and my x is positive. But basically, what is that going to look like? Well, it's just going to be the same as 1 over 1, but reverse. It's going to be going the opposite direction. So it's going to be a 45-degree angle that way. Okay, and then finally I plug in 0, negative 2, and I get a slope of negative 1/2. So again, it's going to be the same as this slope of positive 1/2, but moving in the other direction. And sometimes I mess up and I have to re-sketch it or whatever, but for the most part, I'm pretty good about it. Okay, so that's going to be my negative 1/2 slope. Okay, last column. So again, I'm figuring out the slopes for this final column here. At 1, comma 2, I'm going to have another slope of 1, or 1 over 1, which again just looks like that. Next, I'm going to have a slope of 2. Now 2 is going to be steeper than 1 because it's 2 over 1, so I'm going to have to move up more this way. And again, it doesn't have to be perfect, it just has to be more than 45. So basically, the bigger this number is, the bigger the top is, the more steep it will become. For an example, if I had a slope of 100, well, that's a little bit too extreme. Say a slope of 5 is going to be really steep. It's going to be closer to a vertical line. So keep that in mind as you are sketching your slopes. Now, this brings us to at the point 1, comma 0. So at 1, comma 0, we run into a bit of an obstacle because we get 2 on top and 0 on the bottom, which is a vertical tangent. We've talked about that before. When you get 0 on the bottom and a non-zero on top, you have a vertical. So I'm just going to I'll be drawing a vertical line there at 1, comma 0. Next we have 1, -1. We have a slope of -2, so again it's going to be the same as this. It's just going to be going in the opposite direction, so something like that. And again, that's a slope of -2. And finally, at 1, -2, that we know that's our last point because we went from top left all the way to bottom right. So again, it's important that you're methodical so you cover all bases. So our final slope is going to be 2 over -2, which is -1. And again, it's going to be the same as a slope of 1, but moving in the opposite direction. So it's going to look like this. So those are all my slopes. Now all I have to do for the next step is put all of these slopes on my slope field. So let's start at the first slope we figured out, -1, 2. I'm just going to have a slope of 0 there. So I'm going to go in and I'm going to use a different color here. I'll use burgundy for all my slopes. I'm going to sketch a slope of 0 at -1, 2. In fact, I made that a little bit too big. You know, the question really becomes, how big do you want to make your slopes? Well, you want to make it just big enough to see, but not too big so that it interferes with your other slopes. So at -1, 2, I have a slope of 0, and I'm just going to sketch it right here. Now, if you look at the rest of these in this entire column at x equals -1, all of my slopes are horizontal except at 0. I have no slope. It's undefined. So I'm just going to go ahead and quickly fill in all of these except at -1, 0 because it's 0 over 0. So that takes care of my first column. My second column looks like this. I'm going to have 1/2 at 0, 2, 1 at 0, 1, and then vertical, and then it reverses. So let's go to 0, 2 and sketch a slope of 1/2. Again, it doesn't have to be perfect, but it's going to look something like this. Not quite 45, but close. Next, at 0, 1, we have a slope of 45. So that is going to be closer to 45-degree angle. Next, at 0, 0, we have a vertical slope because we got 0 on the bottom, 1 on top. So it's going to look like this. And then I'm just going to reverse that. It's going to be -1 there and -1/2 there. And then, as you can see, I messed up. I didn't make it quite as slight as I should have. And that will complete my middle column. So again, I did -1 at 0, -1, and then -1/2 at 0, -2. My final column is going to go 1 for 1, 2. So let's sketch a slope of 1 there, or a 45-degree angle. Okay, next I'm going to have a slope of 2 at 1, 1. So 1, 1, I need to put a slope of 2. So again, it's actually going to be steeper than that one, so I'm going to make it look like that. At 1, 1, I'm going to have another vertical tangent, so it's going to look like this. Then I'm just going to go to the reverse again. So I'm going to have -2 right here, and then -1 right there. And that's it, folks. This is my slope field. And this is going to allude to something called a solution curve. So in our next video, we will cover solution curve, which basically means you're going to try to draw curves around these slope fields depending on a particular point. And that will give us an idea of what the graph of dy dx looks like at a particular point. For example, I might want to figure out, I might want to know, what does the graph of y look like if dy dx equals x plus 1 over y, say at 1, 1. What I would do is I would go to 1, 1, and I would try to draw a curve that makes sense, that kind of fits this slope field. So that's the application for slope fields, which is what we're going to look at next. So again, to recap our steps, you're given a differential equation. The first thing you want to do is sketch your field depending on how many grid points you have. They're going to come up with your charts, figure out all your slopes, and finally you're going to sketch those slopes on your slope field. If you have any other questions about this example, let me know.